Hi everyone, my name is Matt, my partner is Liam, and our project was predicting over-under lines for NFL tight end yards. So what is an over-under? An over-under is a bet in sports betting where you have to correctly predict whether some statistic will be over or under some number. Over-under bets have two key components, the line and the odd. The line is the numbers to predict over or under on. In this example, the line is 21.5 yards, and bettors are predicting whether this player will receive over or under that amount. The odds are set by Vegas, and they decide how much payout each bet gets. Here, the odds are minus 110, meaning that if you wager $110, you stand to win 100. Both the over and the under have the same odds in this example, meaning that Vegas believes there's a 50% chance of either happening. In this case, the actual result was 28 yards, meaning those that bet the over won. Like all gambling, sports betting is rigged so that the odds are always in favor of the sports book. Unless you have some sort of competitive edge, you'll lose money in the long run. Therefore, if you can use some machine learning algorithm which is trained to classify a bet using NFL statistics, you can flip the odds in the house. The first thing we did to do this was gather relevant data. We got betting data from a website called PropBet and scraped player statistics and team defense statistics from a website called Pro Football Reference. Getting these statistics was difficult because each player had their own URL to scrape, and the fact that two NFL teams recently changed their names requires us to do extensive wrangling. But after we got the data, we trained 6 different classifiers using the data to see which model was best suited for the problem.
Our data set included 15 features in total, 5 describing the bet alongside statistics from the tight end and the opposing defense. We were able to find a historical data set with prop bet data from the last 4 years, and we extracted data about the bet along with our target variable. Our player statistics tallied stats about the tight end in 3 categories: targets, yards, and percentage of plays on the field. We split each of these into 3 features describing the average, standard deviation, and maximum value of the stat up to that point in the season that the game was being played. We also included a feature describing the average yards the opposing defense gives up to tight ends. We made 2 bar graph visualizations to better understand the composition of our data set. The first figure is a bar graph visualizing how many entries in our dataset are being played at home versus on the road, further broken down by the result of the bet. We learned that the under hit on 57.6% of the bets in our dataset. We also learned that tight ends appear to hit overs more often at home than on the road. The second figure breaks down the proportion of bets with each result by week of the season. Unders were more common in all but 2 weeks, week 9 and week 10. Week 8 was an outlier, with the under hitting on 73.5% of bets. Interestingly, our feature selector ended up keeping week number but did not use home versus away. We also created 2 scatter plots to visualize average tight end yards and average tight end defense versus the line set for the game. We learned from the first graph that the bets where tight ends averaged a lot of yards per game nearly always ended up being unders. This could be attributed to Vegas overreacting to outlier performance in the first few weeks of the season. We learned from the second graph that unders frequently hit when the line is set above the average yards given up by an above-average defense. Overs commonly hit against defenses that struggle to defend tight ends regardless of where the line is set. Displaying the data in a scatter plot like this lets us see that lines close to 70 tend to almost always be overs. After selecting the most impactful features and performing hyperparameter tuning, our best algorithms were our neural network, logistic regression, linear support vector, and decision tree. We have 4 algorithms that appear to be able to classify tight end prop bets correctly around 60% of the time. While this might seem low compared to some other projects, we're satisfied with our results. Our goal for the project was to build a model capable of making money in the long term. Vegas creates lines to be as close to 50-50 as possible, so any model that predicts better than 50% can be profitable. We plan to use our model to identify the bets each week that our estimators are most confident in, and hopefully stop losing money. We intended for our opposition tight end defense feature to be the average yards per game given up to tight ends so far that season, similar to the method we did for our tight end statistics, but we couldn't find the data to scrape to calculate this. So the compromise we had to make was to instead use the average yards per game given up to tight ends over the whole season. Additionally, our model would benefit from having more data to train off of. We were only able to find bet data from the last 4 years, so we have a total of about 1,000 bets. We also created our dataset during week 7 of the regular season, so we're missing data from the remainder of the 2020 season. If we were to further improve our model, we would look into creating features about individual matchups and the way defenses cover tight ends, instead of our current generalizations